Hello and welcome to the free CCNA CyberOps instructor training on the 30th of September 2019. Chapter 3, the Linux operating system. Okay, I can see quite a few people starting to connect. We'll give it a few seconds just to make sure that we've got everybody who's streaming in on the start. Good evening, good morning, good afternoon, good night, depending on what time zone you're in. That's young Andrew Smith has joined us all the way from Croatia, I presume. Yes. Good evening to everybody. Excellent. Okay, so I love Linux as well, Irene. Yeah, my favourite. Andrew is in the airport. Is that the airport in Croatia waiting to head back to the old UK? I tell you what, there's some good air miles, does there, Andrew? Yeah. I think Captain James Tiberius Kirk would quite like Andrew Smith's air miles. Yeah. I don't think he clocked up as many miles on his 5-year mission. Okay, anyway, enough of that. We are now on Chapter 3. Chapter 3 being the Linux operating system. I've been quite looking forward to doing this chapter with you. So we shall begin. And what I'm going to do first of all is I'm going to show you very quickly how we can install a Debian system in VirtualBox with a graphical user interface from the start. We'll do it fairly quick. I've used cunning plans to sort of speed up time on this one a little bit. So if we switch across to my Google web browser and let's see what we can do. So of course the very first thing that we need to do is get hold of the installation media. So we'll go and ask good old Uncle Google and we'll tap in Debian, and that will give us access to the Debian CD USB ISO images. We go to download CD DVD ISO images using HTTP. I'm not going to use the big images. I'm actually going to go instead for the net install image, which is a fairly small image, only about 150 to 300 meg in size. So this will take us through to the net install link where we can download the images either using a BitTorrent link or just using standard HTTP, which is probably the better way of doing it for this video. You'll notice that there are many different processor architectures that we can install Debian on. However, we will select the AMD 64 image, which is for Intel and AMD 64-bit processors. Now you will notice that I've already downloaded this image, even though it's relatively small. It's about 335 meg download, just to speed things up a little bit. Okay, so you will see in my downloads folder, among many other things, we've got the Debian 10.1.0 AMD 64 net install image. So this is for 64-bit Intel and AMD processors, 335 megabytes in size. While we're here, what I'm going to do is I'm going to right click on the terminal window. So I'm going to right click in the file manager and select the terminal window. And I'll just show you a few little Linux tricks because this is the Linux chapter. Okay, so we can do an ls-l just to give us a long listing or a detailed listing of the contents of this directory. In here you can see that I have a directory called Linux, but I also, more importantly, have a file called Debian. Now the size of this file is currently in blocks, so what I'll do is I'll do ls-thor, nice easy one to remember, and what Thor will do is it will give us it in human readable format, among other things. So we've got 335 meg in size. We'll use the file. File is a nice command. File will actually inspect that file and tell us a little bit about it. It will show us that this is actually a bootable image. So this ISO image is designed to produce a bootable system. So we can actually we can boot to this in order to do an install. You can see that we can do an MD5 sum straight from the command line. We can do a SHA-1 sum straight from the command line to find the MD5 or SHA-1 hashes. We can compare these with the hashes on the website to make sure that our installation media has been downloaded in a uncorrupted format. Always important if you're installing an operating system. Okay, so now what we'll do is we'll fire up VirtualBox, and we'll use that net install ISO image as the installation media to install our Debian system with a graphical user interface. It's great to get your students using Linux distributions, and Debian is one of the best ones to start on. In fact, Kali Linux is based on Debian anyway, and so is Ubuntu for that matter. So I'm going to give this VM a name of Debian GUI because it's a graphical user interface version. The name has basically allowed me to see that VirtualBox has already selected it's a Linux image in 64-bit. I'm going to set the memory, the amount of RAM to 2 gig or 2048 meg. Create a virtual hard drive, a VDI image. I'll leave it to the default dynamically allocated. Because it's a GUI, I'll make it a little bit bigger than the default of 8 gig and change that to 10 gig. And then there's just a few little bits of fine tuning that I wish to do. One of the first bits of fine tuning, I'll click on System. I'll remove the floppy disk drive because we don't use those things anymore, and I'll send that right down to the bottom of the boot order. I'll go to Display. I'm not going to change anything in the display, but you might want to increase the size of the video memory if you're going to run it across multiple monitors. More importantly, I'm going to click on the CD-ROM drive, and I'm going to insert the Debian ISO image that we downloaded earlier directly into the CD-ROM drive. Because VirtualBox will allow us to boot off of that ISO image, effectively treating it as a CD-ROM. I will select Bridged Adapter on the network properties, and I will bridge it to my Ethernet adapter that connects me to the internet, so I've got a good internet connection to my virtual machine guest, and then we'll start her up. Okay, so you can see it definitely is a bootable image. We've got the graphical install running. What I'll do is I'll click down to the actual normal install. I like to do the install using what's called N curses. Rather than use the full graphical install, this is what they call the N curses interface. I'll just select UK, British, English for the locale, the keyboard, etc. And then we'll start the installation process up. It's going to try to auto-detect an IP address using either IPv6 auto configuration or DHCP. It will succeed with DHCP and get an IP address from my router. I'll change the host name to Debian 10. I won't bother with a domain name. I'll create a root password, just something straightforward because it's only used for a lab. I'll create a normal user, Kevin Large, that is I. It will guess the username from that of Kevin. Linux usernames are always lowercase in a single word. I'll tap in the password for the normal user, and then off it'll go, getting ready to partition the hard disk. I'll use the guided, use the entire hard disk, and select the only hard disk I have, the one I used created in VirtualBox. I won't create any extra partitions. I'll just put everything into one partition, and I'll write those changes to the disk. And at this point it will start doing a base system installation, just installing enough to get the hardware working, and to then progress on to the point where I can do things like, for instance, indicate where I'm going to get my software from, which advanced package management tool repository I will use, and what type of software I wish to include. We don't need to scan any other installation media. I will select the United Kingdom as my nearest apt repository, and I'll just take the default web server. So this is where it's going to go to get any software that I need to install. I can simply apt install software once this is set up. Apt being the advanced package management tool, which is the standard package management tool for Debian and Debian based Linux distributions. And then off it'll go, and it will retrieve various files to configure the advanced package management tool software, and it will work its way nice and steadily through the select and install software stage. One of the nice things with this is it will pull up what is known as task cell or task selector, which is like a little template that we can use in order to select the major software installation that we require. Do we want it to be a web server? Do we want to have SSH? Do we want it to be a print server? Do we want it to use the GNOME GUI or the KDE GUI or the XFCE GUI, for instance? Here we go. Here's Task Selector. What I will do is I will navigate down to where the star is in front of print server, and I'll hit my spacebar to remove that because I don't want it to be a print server. But I will select SSH server by hitting the spacebar again. I won't use the standard Debian desktop, so I'll unselect the star by the side of Debian desktop, again hitting the spacebar, and I'll use a lightweight desktop, XFCE. Once I've selected what I wish using task cell, I'll just continue, and at this point it will start doing the main software installation. Now, through the magic of flux capacitors and 1.31 gigawatts of power, I can speed this up a little bit. There you go. It's very nearly pulled all of that information already. It's now going to start unpacking the files that we've downloaded and installing the main components of the complete operating system, including the kernel, the major applications, the graphical user interface. That's very nearly installed all of the software already. It's now going to install the Grub bootloader, the Grand Unified Bootloader, which starts the system up. That will go in the master boot record. So I will select master boot record for it to install into. I will enter the device that is dev SDA, SDA being the only hard drive that I actually have. It's the one I created when I created this virtual machine in the VirtualBox Manager. The installation is now complete. It'll do a reboot. Now, the reason I wanted to show you this was because of the next step in particular. I'm going to show you how you install the virtual machine guest editions. This allows you to resize your display. It also makes it a lot more stable and a lot smoother. Now, when you try to install VirtualBox guest editions on certain versions of Linux, it can be slightly more demanding than in Windows and require a greater level of technical ability. So I'm going to show you exactly how you get around things now. We'll try to do it the simple way, and you'll notice it won't work. Now, without guest editions installed, when you expand the size of the window, the actual size of the guest Linux desktop just stays the same size as usual. I do actually have the ability to change the desktop to certain values because the VirtualBox graphic adapter is recognized by Debian, so I can actually select some preset values and change the desktop size. However, even when I do that, if I try to drag the sides of the window, it still stays stuck at that size. And the VirtualBox guest editions are not installed at this point. You watch, I try to drag the window and the desktop still stays the same size. It's good to install the VirtualBox guest editions. So if we try to do it the simple way, going up to devices, install guest editions, it'll ask us to try to download it. We'll give that a try. It will fail, at which point many people who haven't used Linux before start scratching their head or crying. There are ways around this, and I will show you how to fix it. It is slightly more technically challenging, but this is one of the lovely things about Linux, is it's like playing a game of chess. Sometimes you actually have to sit down and really carefully think about things. It's not a case of next, 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 finish. So you'll notice that failed. Okay. What I'm going to do is I'm going to actually copy that location. I'm going to do a download. So I'm going to copy the location where it gets the guest editions from. And in fact, I'll do it an even simpler way. I'm going to look at the version of VirtualBox we're using, which is 6.0.10, and then I will go to the internet on my host machine, not the guest, not the Linux guest, but my host machine, which is my Manjaro Linux machine. In this case, it would probably be your Windows machine. I'll type in that I'm looking for VirtualBox 6.1.0. This will take me to the download virtualbox.org link, and I can find the guest edition's ISO image from that link. I will save that to my host virtual machine, my big powerful host virtual machine that the Linux guest will be running on. And you'll see that I'm now downloading that from the downloads.virtualbox.org website. And what I'm going to do is I'm actually going to go back in a moment into my virtual machine because it's still running, and I'll just power down the virtual machine, because what I'm going to do is I'm going to take this ISO image and I'm going to put it in the CD-ROM drive so as it's accessible by my guest virtual machine. So you'll see in storage currently the CD-ROM drive is empty. It did have the installation media in to create this Linux machine. Now it's empty. What I'm going to do is not quite downloaded yet, it's almost there. Three, two, one, bang, it's there. Okay, I'll just open that in File Manager just so as I can show you it. We have the VBox Guest Editions ISO image, and I will be putting that inside the virtual CD-ROM drive on my Linux VM in a moment. I'll just very quickly show you how big it is. Again, that's showing it in block size, so I'll just use LS Thor. You see it's not a particularly big download, 74 meg. If we use File to have a look at that Guest Editions download, you'll see that it is an ISO 9660 CD-ROM file system. So basically it's designed to burn to a CD-ROM drive, or in the case of VirtualBox we can put VirtualBox to point directly at it and it will treat it as a CD-ROM. So I'm going to click on the CD-ROM in our Linux guest, and I'm going to select the VBox Guest Editions ISO. So when I start up the Linux guest, it should see it in its CD-ROM drive. We'll start the Linux guest now. Tap in my username and password. And what we should see, hopefully, is a VBox CD-ROM, and it's there on the desktop. However, currently it's not mounted. What we have to do in Linux is, in order to read and write to a piece of media, we actually have to mount it. That allows us to read and write to it. So what I'm going to do is I'm going to become the root user, tap in the root user's password, which we created when we did the install, and I'm going to simply cd to my root user's home directory and tidy up the screen. I'll do a df-h, df space -h, which will show me all of the file systems on my Linux machine. And we can see that dev SRO0, which is my CD-ROM drive, is mounted to /media CD-ROM. If I change directories to /media CD-ROM and do an ls-l, you can see the contents. What I'm now going to do, because the CD-ROM is read-only, I'm going to make a directory in my root directory, the root user's home folder, root, called 1234, and I'm going to copy everything recursively, so it will copy anything inside folders as well, from the CD-ROM drive into the root 1234 directory. So cp minus $R* will do a recursive copy of the entire contents of the CD-ROM and drop it into my root 1234 drive. I've just changed to the root 1234 directory, and in there is a file vbox linux editions.run. I'm going to run that by typing ./vbox linux editions.run, and you'll notice we have a problem. Yep, that's what I love about Linux. Things are not always completely straightforward. Okay, the problem is that kernel headers were not found. You may see a line there that says kernel headers not found for target kernel. So I'm going to work out what my kernel is, the kernel being the part of the operating system, the core of the operating system. And the kernel on this is Debian 10 4.19.0 6 hyphen 0-6 AMD64. Okay, I'm going to do an apt update to make sure that I'm completely up to date as to where I pull my packages from and what versions of packages I can get. And I'm going to do an apt upgrade. And you see, because I've done this as a very new install, there's nothing to update or upgrade. So I'll now search for anything in the package repository that starts 4.1906 AMD64, and that has allowed me to find the Linux headers that are missing. So I'm going to now apt install those missing Linux headers. The Linux headers are used when you have to build software against the kernel. So it's now pulling the Linux headers and any dependencies that it thinks that I may require. Again, you may, if you've not used much Linux, need to watch this a little bit again, but that's the beauty of a recording. Now, if I try to run VBox Linux Editions run, it'll almost work. It's not looking for the Linux kernel headers anymore, it knows they're there. However, I'm getting another little error now. I'm getting an error saying that GCC, which is the GNU C compiler, make and Perl packages need to be installed. Now, to be fair, GCC 8 is installed. I can already see it. It installed it in the previous step. So this is where it threw me just a tiny bit, but I'll show you my logic here, the way I was thinking. I've done an apt install of Perl. It's said that Perl's already the latest version. And I've done an apt install of GCC. And I forgot to apt install make. Okay, so at this point I tried to do a reboot, and in fact I was a little tiny bit flummoxed there because I tried to reboot it as though it was a Raspberry Pi. So I'm now doing a restart, and I'm going to try that command one more time. However, what I did, I installed GCC and I installed Perl. You can see that the VBox guest editions are still not working at the moment because I can't resize the screen properly with the display following the resize. I'm going to cd into root 1234, try running that command again, see what error I get. I know it's not worked because I can't resize the screen properly. Now I'm looking at it and it says please install GCC make Perl. It's actually as plain as the nose on your face what the problem is. I fixed GCC, but I didn't fix make. Perl was already the latest version. So all I've got to do now is install make. However, it's still throwing me at this point, but I wanted to show you my logic here. I'm thinking, is that really not working? And of course it's not working. Yeah. So now it suddenly comes to me. Kev, read the error. Whenever you're looking at installing anything in Linux, always make sure you're very careful to read any errors that pop up, because quite often they'll tell you exactly what the problem is. So I'm now going to run VBox Linux Editions run, and on this occasion I actually looked a bit more closely at the error and realized, you know what you haven't done? You haven't updated the version of make. GCC's okay, Perl's okay, I didn't do make. So what I'm going to do now is I'm going to run apt install GCC make and Perl. It's told me that GCC and Perl are already the newest version, but make I'm going to fix. And it's fixed make. Now when I run /Linux editions, it sits there for about 3 or 4 times as long. I can remember thinking, something's definitely happening now because it's taking longer. And yes, it's now doing an update of what's known as the init ramfs. That's the initial RAM file system. And the VBox guest editions are installed. It worked. Big smiley face. Yes. Thank you very much for whoever hit the like button there. Yeah, it did work at last. Okay, we'll do a restart. We'll log in. It boots up, but now when I try to resize the window, watch what happens. Yeah, the display resizes perfectly to match the size of the window. If I go to settings and look at the display, you'll notice it's got a really odd size in there because it's actually just resizing to the size of the window I wish. VBox guest editions are installed. This will make the system much more easy to use, much more stable, much more responsive. Okay, so that's how you go about installing VBox guest editions. And I now have a nice Debian Linux graphical user interface virtual machine, which we can use later on. I've gone into the terminal and I'm now going to change the appearance of the terminal window. I'm just going to show you very quickly how you change the font size. Why am I doing this? Because your teachers, your instructors, you're probably going to want to show your students how to do this on a projector. If they're sitting up at the back of the room, it makes it easier for them to see what's going on. So I've changed the font size. I'm now going to change the colors. I'm going to create the custom text color as black, and the background color I'm going to create a custom color of light yellow. So again, if you've got any students who are dyslexic, or even if they're not, it's very soothing to have black on a light yellow background. So this hopefully will be a little bit better for your students to look at. I'm going to do a df-h disk free space human readable format, so it shows me all of the file systems on the computer. I'm going to do a free -m, which shows me the amount of memory in use, free and available. I'll do an IP-A to show me any IP addresses, and it's good to go. And there you go, that's how I went about speeding up time. I actually did a pre-recording and did it in VLC, so you've just watched a recording of a recording. Crafty. Now, what we're now going to do, we'll start the actual presentations slides. So what is Linux? Linux is an open source operating system. It was created in 1991 and it's maintained by a community of programmers. Wonderful programmers. Lovely people. Open source simply means that the source programming files, this includes the kernel, the core of the operating system, the thing that talks directly to the hardware, the shell that the user talks to, and all the applications are available for downloading, viewing and modification. The actual source code is freely available on the internet. If you are a good programmer and you know how to do it, you can modify that source code and make it work better. It's not like a proprietary operating system where the source code for the operating system is kept very securely in a safe and only allowed to be seen by the people who work at the company and specialist developers. Okay, open source, available to anybody. If you can make it work faster, good on you. Go ahead, go for it. You can't claim it as your own because you were given it for free. You can't claim it as your own. So, you know, do the decent thing, make it work faster, and then put it back out on the internet for everybody to use. Linux was designed from the ground up as a network operating system. It's based on Unix. This is a very, very powerful operating system that was used on mainframe computers, among other things. Linux can be used on widely differing platforms, including embedded systems. It's quite possible that your home router, or your firewall, or your network attached storage device is running Linux. There are many, many different versions of Linux or distributions. In fact, let's see if I can show you just very quickly. If we go to Google and I type in distro watch, put the fun back into computing, use Linux. There you go. DistroWatch basically tracks Linux distributions. It shows you the distributions as they come out, as they're modified, as new versions come out. We can see development release of Ubuntu 19.10 was released on the 27th of the 9th. CentOS, etc, etc, etc. We can see the various popularities of different versions of Linux. You notice Debian is there. However, Mint is based on Debian. Ubuntu is based on Debian. I would imagine if you actually looked at all the different Linux distributions and you worked out which ones were based on which, there's three main ones. There's Red Hat and distributions based on Red Hat, like for instance CentOS, Mandrake, SUSE. It's roughly based on Red Hat. There's Debian, and the versions that are based on Debian, like Ubuntu and Knoppix and Mint, and Kali Linux, of course. And then there's your Slackware, and there's various other ones as well. In fact, if I click on the all distributions, you can see that's just the A's. Now we're on to the B's, C's. There are literally thousands and thousands of different Linux distributions. What they do is they take the kernel of the Linux operating system and then they build a distribution around it with different graphical user interfaces, file managers, etc. Okay, so there are many different versions of Linux or distributions, and a distribution is defined by its kernel as well as the programs and software packaging. So Red Hat will use RPMs, whereas Debian, for instance, would use DPKG. Deb packages, which could be installed by DPKG from the command line, or apt, the advanced package management tool. Some Linux distributions are free. In fact, nearly all Linux distributions are free. We like free, like CentOS, Fedora, Debian, Mandrake, etc. Others, like Red Hat Enterprise Server, cost money. However, they include support services. In reality, you're not really paying for the distribution, you're actually paying for the support services. But some of the distributions you can't really buy without the support services. It's fairly rare, but does exist. The value of Linux. So Linux is an operating system of choice in the Security Operations Center. So this is how it relates specifically back to this course. In the SOC, Linux is not an operating system of choice. I would probably go further than that. I would say it is the operating system of choice. It's open source, so it allows analysts and administrators to build tailor-built custom versions of the operating system. The command line interface is extremely powerful. So this enables analysts to perform tasks directly and remotely from a terminal. It has more user control over the operating system. So the root user, or super user, has absolute power over the computer. They can modify any aspect of the computer. It's an incredibly flexible, powerful, stable, secure, reliable, efficient operating system. Do you get the feeling I like it? And it has better network communication control. The TCP/IP stack on the Linux system is extremely strong and extremely efficient. So this helps with network capable applications. Okay, so Linux in the Security Operations Center, we can develop a custom security distribution of Linux specifically for the Security Operations Center with precisely the tools that are needed to do the job. Tools like, for instance, Wireshark for packet captures, malware analysis tools, intrusion detection system tools, firewalls, log managers, security information and event managers, ticketing systems. These can all be incorporated by custom into the Linux distribution. We can have tools for penetration testing, for looking for vulnerabilities, packet generators, port scanners, proof of concept exploits. The Kali Linux distribution has literally hundreds of security tools. You could spend a considerable amount of time working your way through Kali Linux. It would probably take a couple of years to try absolutely every tool on Kali Linux. The Linux shell. So the user communicates with the operating system using either a command line interface or a GUI. Now the terminal emulator applications, these provide access to the command line interface. And these could be things like Terminator, eTerm, Xterm, Console, GNOME Terminal. And then we've got various commands, mv, move, chmod, chown, dd, etc. I think it would be at this point a little bit more fun if I brought up a newly installed Linux operating system, the one we created earlier. So let's have a little look, see if we can do that. Okay, you should now see VirtualBox Manager. We have the Debian GUI that we created earlier, so I'll fire that one up. And we'll have a little look around, see what we can do. So our Debian GUI system is now loading up. Excellent. I will log in as the user Kevin. I didn't like that. Let me click in the window a bit harder. That's better. That was a bit worrying. As the user Kevin with the password QWERTY. This is using a graphical user interface known as XCFE. Okay. And what I'm going to do while I'm up here is I will click on the terminal. And this is one of the terminals that we were talking about. This is a shell. This gives us command line access to the system. I'll maximize that. And while we're in the system, we'll have a little look around and we'll have a little play and see what we can do. So currently, if you look at the prompt tells us an awful lot. It tells us that the user that I'm logged in as is Kevin. I'm on a system called Debian 10. The little tilde, the little squiggly line, means I'm in my own user's home directory, and the $ means I'm just a standard user. I'm not the super user or administrator. I can find out a lot of that information by typing "Who am I?" It says you are the user Kevin. Host name, I'm on a system called Debian 10. PWD, print working directory, print onto the screen where I am in the system. You're in home Kevin, user Kevin's home directory, which is why I have the little tilde. I can type ID. That will give me all of the user IDs and groups and various groups that I belong to. I belong to the Kevin group. Each user has their own group. I also belong to the CD-ROM group, the floppy group, the audio group, and various other groups, video groups, NetDev groups. NetDev groups meaning I can use the network card, Bluetooth groups. You can see where they're coming from on this one. LP admin, group that allows me to administer LP, which is the line printer. There are so many commands that we can do from here. Let me see if we can just do something for a bit of fun. Okay, what I'm going to do is I'm going to bring that window down a little bit in size, and I'm going to see if we can open up a file manager in the background as well. So there we go. So we have the file manager on one side. We have the command line interface. So a shell, in this case a command line interface shell on this side. If I type pwd, we can see we're in the home Kevin directory, which is exactly where we are in the file manager, /home/Kevin. So if I do an ls, I should see that we've got 1, 2, 3, 4, 5, 6, 7, 8 directories. Directories are highlighted in blue. We've got 1, 2, 3, 4, 5, 6, 7, 8 directories. The desktop just looks different because there's a different icon for the desktop, but it is a directory. I can do an ls-l, which will give me a long listing or a detailed listing of those directories. So I can see that we have a D in front, which indicates that it's a directory. I can see the permissions, read, write and execute for the user or the owner, read and execute for the group, and read and execute for others, anybody else. So the user has read, write and execute, the group has read and execute, and anybody else on the system has read and execute. I can see the owner, in this case it's Kevin, the group is also Kevin, and various date and time timestamps. Okay, what I'm going to do is I'm going to go into the downloads folder by double clicking on it in the file manager. I'll do the same thing in the graphical user interface. So we'll do a CD downloads. I can hit DOW and then tab, and because that was enough letters to be unique, it will finish the rest of the command for me. I'm now in the downloads folder. I'll just clear the screen by typing Control L. I'll now do a pwd. You can see I'm in home Kevin downloads. There is nothing in this folder. If I do an ls-l, you'll see there's nothing there. If I do an ls-la, which shows hidden files, you'll see the only thing that's here is ... which basically means go back a directory, and dot, which means this directory. So I've got this directory and go back a directory, and that's all that's in here. What I'm going to do is I'm just going to graphically right click and create a folder, and I'm going to call that folder space 1. And there it is. Now I'm going to do that ls-l again. You can see we have folder 1. Okay, that's all very well and good. What I'll now do is I'll right click and delete that folder. I would do if I could find out where the devil delete is. Move to the wastebasket, that'll do. Okay, so we'll now do an ls-l again and it's gone. However, let's try something different. mkdir, make directory. And what we'll do is we'll make directories. I'm going to make 100 directories called folder 1 up to folder 100. That would take a long time graphically. So what we're going to do is we're going to say folder \. You have to put a \/ in to escape the space. So \/ space curly bracket 1 ... 100 end curly bracket. What that command will do is it will use folder followed by a space, and it will say folder 1, 2, 3 all the way up to 100. And there you go, we have 100 folders. Try doing that with a graphical user interface. Take a fair while, wouldn't it? Okay, so this just gives you some idea, a little tiny silly way of demonstrating to your students the sheer power of a Linux command line. And what I'm going to do is I'm going to remove those folders now. So I'll do rmdir. And all I'm going to do is I'm going to put asterisk, which means everything. You can see the whole lot's gone. Okay, this is good. What else can I do while I'm in here? Touch will create a file, an empty file. Again, I could create multiple empty files by using the brackets expansion. I'll just create 10. There we go, file 1 to 10, and these are simply empty files. It's interesting enough, it's going to try to open it with LibreOffice, which is a bit of an overkill because that's a full-blown Office package, which is capable of doing text, spreadsheets, presentations, drawings, etc. Again, completely open source, free software. Okay, we'll get rid of those, so I'll do an rm, because these are not directories, so I'll just remove everything. Okay, I'll do a Control L. Let's have a little look at some of the other commands that we might wish to do. I'll just drop that. chmod, chown, dd. We won't have time to do all of these, but chmod and chown are quite useful ones. I'll show you how that works. So let's just make a file. I'll make a file using touch, and I'll call it Bob. Okay, and then I'll do an ls-l, and you can see that we have a file, and that is a file, not a directory, because there's no D in front. We have read and write permission on that file for the owner, the user, read permission for the group, and read permission for everybody else. And because I created the file, it's owned by me, and its group ownership is also me. I'll show you very quickly how we do chown first. What I'll need to do is I'll actually need to create another user, because there's only one user on this system at the minute. So see, can we use add user? Ah, I know why. I need to be the root user to create other users. So I'm just going to become the root user, and let's see, that's interesting. They changed the commands on this thing. Well, I'll be a monkey's uncle. That's odd. It's been a little while since I've used Debian. The last version was Debian 9. They couldn't have changed the commands to create users, surely. No, user ads exists. Ah, I know what it is. I probably didn't type enough of the command for it to be unique. So, let's see if we can do a user ad Joe. User ad does not exist. Whoa, this is interesting. They've actually done something strange with the commands on here. That makes me think that add user probably doesn't exist either. Wow. Well, that's a bit interesting then. So how are we creating users now? Unfortunately, I don't have time to go into how you create users on a Debian system because we'll run out of time for the presentation. But what I will do is, because this interests me, I must admit, I will I'll make a little supplementary video of how we can create users on a system. That's very, very strange. Very strange. I'll tell you what we'll do then. In the meantime, we'll chown to the root user, because the root user exists. So we'll change the root user, and we'll also change to the root group as well. So we'll do root:root Bob. Okay, now when I do an ls-l, you'll notice that the ownership of this file has changed to root instead of Kevin. Okay, let's just refresh that file in the file system. Notice it's now opened in read-only mode. Yeah, it didn't do that before. It's now in read-only mode, and of course the reason it's in read-only mode is in the file manager I'm trying to open it as Kevin, and it's now owned by root. So root has read-write access, but Kevin does not. That's interesting. Okay, we can change the permissions with chmod. So for instance, if I type 777 Bob, what that will do is that will change the user, the group, and anybody else on the system to have read, write and execute permission. The reason it's 777 is it takes those three blocks and it uses what's known as octal. So the right handmost block, the execute bit, is given a value of 1, the right bit has a value of 2, and the leftmost bit, the read bit, has a value of 4. So it goes 1, 2, 4. And obviously if you highlight all four of them, read, write and execute, it will mean that you've got 1 plus 2 plus 4, which is 7. Just to give you a for instance on that one, if I instead change it to 707, what we should see is we should see read, write, execute, nothing, 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 read, write, execute. There we go. Okay. Either way, others has write permission now, so if we open that folder, you notice the read-only has now disappeared because we do actually have write permission on there as well. Okay, that's useful. Right, so there are many, many, many more commands that you need to work your way through. There are lots and lots of labs in this chapter, so I recommend that you do have a little look at the labs. There's some really good labs using the virtual machines to get you more used to Linux. We've had a little look at the ls command, the cd command, we've done a make directory. We haven't done a copy. Well, actually technically we have done a copy, because when we did the installation of VirtualBox guest editions, we used cp space hyphen capital R. We did a recursive copy from the CD-ROM drive into a folder. We did the RM to remove files. Okay, so working with text files, there are many different text editors available in Linux. Vi, Vim, Nano. So let's have a little look. What have we got on our distribution? Let's just become the normal user again. So I'm going to do an exit. Go back to being the normal user. I'll double check that I am the normal user by typing who am I, but I can tell that from the prompt anyway because it says Kevin. While I'm in here, I'll do a pwd to make sure I'm in the right place. Home Kevin downloads. I am. Watch what happens if I try to remove that folder, that file Bob. It goes. Aha, that's interesting. That surprised me slightly. What were the permissions I put on it? Well, I have actually got read, write and execute permission for others as well, so that's fine. Okay, that's why I did manage to remove it even though I didn't own it. What we will do is I'll just pop back very quickly to see what I was going to do there. That's it, text editors. I'm going to use Nano, which is a text command line based text editor, to create a file called Fred. I'll even put .txt on the end. Not that Linux needs to have an extension. Linux doesn't require an extension, but if I send this across to a Windows machine, it will make it a lot easier for the Windows machine to open with .txt on the end. And in that file, I will put hello and a smiley face. Now, in order to save the file in Nano, you have to hit Control O. You can actually see the menu at the bottom of the screen there. The little up caret is the control. So Control O is write out. And you'll notice as soon as I wrote it, it appeared in the file manager. And then Control X to exit. Now if I open it in the file manager, you can see it says hello, smiley face. So we got text-based, command line based text editors. There are also very probably a graphical text editor in here. In this case it's Mousepad. Yep, so we've got Mousepad. I can use Mousepad to open Fred.txt. Okay, this is virtually like Notepad. So other text editors like gedit or Mousepad are GUI based. The nice thing with a CLI based text editor is it allows system management remotely via, for instance, SSH. We'll show you that in a moment. The importance of files in a Linux file system. Key thing, in Linux, everything is treated as a file. So this includes the memory, the disks, the monitor, everything. Everything is a file. This is actually very useful because it allows us to use standard file editing utilities and operations to work on just about anything. The operating system, as well as most of the programs, are configured by editing configuration files. These are text files. Editing a system or application configuration will require superuser or root privileges. So this can be accomplished using sudo if you're using, say, for instance, Ubuntu, or on a pure Debian system you would just type su and type your superuser password, though you can set up sudo to work on a Debian system as well. Client-server operation. Servers are computers with software installed that enables them to provide services to clients. So for instance, file servers, email servers, web servers. We can turn our Linux machine into a server very straightforwardly. We'll do that now. So here is our Linux machine. What I'm going to do is I'm going to run ss minus tln. SS is the replacement for netstat. TLN, T for TCP, L for listening, N for numerical. What this will do is it will show any listening sockets, TCP listening sockets, using a numerical port number. So in this particular case, a socket is a combination of a IP address and a port number. So the IP address 0000 means basically any IP address on any interface. And we're looking at TCP port number 22, which is owned by SSH. In fact, if I remove the N, you'll notice SSH. So I know this system is already, this Linux system is already a SSH server. But that's the only port I can see. What I'm going to do is I'm going to try to turn it into a web server. I like living on the edge, so this is a demo that we're doing off the seat of the pants. I'm going to try to turn this into a web server. Before I do that, I will type IPA to find the IP address of this system. The IP address of this system is 192.168.50.71. And what I will do is I will open up on my big host machine, the one I'm recording the videos on. I will open up a web browser. What are you doing, Kev? You're opening up a web browser, that's right. And in that web browser, I will type in that address, 192.168.50.71. We'll just see if there's anything on there. This site can't be reached. That is not at all surprising. Okay, it will be reachable in a moment. We'll slide that web browser window out of the way, and we'll see if we can install a web browser on our system. I'll need to become the root user in order to install software. I'll do a CD and a Control L just to clear the screen. Now I will do an apt install Apache 2. Yes, please. What this will do is this will pull all of the software required to install the Apache 2 web server and all of the dependencies that are required to make that software work. It's already pulled it, uncompressed it, and installed it. That's how easy it is to install software on a Linux machine. Wow. If only all operating systems you could install software that easily on. Okay, what I'm now going to do is I'm going to run that command again, ss-tln, TCP listening sockets numerically, and you will notice that we have a new listening socket, port 80. Port 80, of course, is the socket for web servers. So now what we should be able to do is bring that page back in again and refresh the page. There we go. Simple as that. We have a web server listening. You can see it says it works up the top there in red. We can try something else. See if this will help. Nano, as it said, all applications are configured by files, so we'll do nano var www html, and in there we should have index.html. That is the code that created that web page, and in here we can actually see the HTML CSS code that created the web page. What I'm going to do is I'm going to use the Control W for where is to try to find it works exclamation mark. It works exclamation mark. Okay, we can see this is a section that's got a red background and it says it works. Bring the page back in, red background, it works. Let's change that. So what we'll do now is see if we can change this. And what we'll do is we'll put in, just for speed's sake, it really works. Okay, Control O, enter, Control X, bring the web page back, hit the refresh. It really works. Okay, so that is the client-server relationship. On our Linux system we have a web server now running, and in my Chrome window on my host machine we've browsed to that web server. The web server was listening for connections. It's allowed a connection from my web browser, and you can see that it's serving up a web page. How cool is that? Right. So, client server, we have a web server listening on a specific IP address and a specific port number, a combination of an IP address and port number being a socket. It has the job of listening for requests from the client The client was the Chrome window on my host operating system. So the client software is designed to communicate with the server. In this particular case, Chrome sent out what's called a HTTP GET request to get a web page, and the server dished up that web page. Oh, how cool is that? Okay, we better speed up just a little bit now because we're starting to run a bit low on time. That was good. We've already had a quick look at what a port is. So a port is a reserved network resource used by a service. The administrator can assign a port to a specific service or use a default port number. You can see that the default port number for Hypertext Transfer Protocol, HTTP, is port 80, which is precisely what we could see on our Debian system. It's listening on port 80. Okay. If this was an email system, it would probably be using ports 25 and 110, which is Simple Mail Transfer Protocol for sending emails, and 110 POP Post Office Protocol version 3 for receiving emails. Or if it was a little bit more sophisticated, it would be using port 143, which is the Internet Message Access Protocol. Okay, I don't know why it's got NTP on there. That looks like that was a typo, because NTP is the Network Time Protocol. Okay, so a client is a program or an application designed to communicate with a specific server. The client applications will be using a well-defined protocol such as FTP, which uses port numbers 20 and 21, or HTTP, Hypertext Transfer Protocol, which uses port number 80, or HTTPS, which uses port number 443. Notice I can reel these things off very quickly, because if you do networking at a reasonably high level, especially if you need to configure firewalls, you need to know your port numbers, what applications run on what ports. Configuration files, we've already had a quick look at a Linux server configuration file. That was the configuration file index.html, which lived in /var/www/html, and this was the configuration file for the default web page of the Apache web server. The configuration files define all kinds of options for the service, such as the port number, the location of the resources, etc. In fact, that file index.html was literally the configuration file for the default web page. The web server itself also has a configuration file. Hardening devices, we need to make sure that we ensure physical security. The devices should be locked in a rack in a secure server room. We need to minimize the installed packages. Every package you install, especially network capable packages, is another backdoor into the system. Disable any unused services. Use SSH and disable the root login, so as you can't log in as the root user over SSH. SSH uses high-level encryption. Do not use Telnet, which sends everything in clear text. Keep the system updated. Latest updates, service patches, kernels, etc. Disable USB auto detection. Enforce strong passwords. Force periodic password changes. Keep users from reusing old passwords, and always review your log files regularly. Okay, log files are stored in various places on the Linux system. var log messages being the main store for informational and non-critical services, and there are many others. Different types of file systems in use in Linux. We have the extended file systems, so X2, X3, X4. X3 and X4 have journaling, where it makes use of specialized indexes, multiple indexes, so if there is a file system crash, it can recover very quickly. We also have things like the NFS file system. Nice thing with Linux is it will read most other file systems as well, and it will also write to many of them. So for instance, the Linux system can read and write to FAT32, used by Windows. In fact, if you set it up correctly, a Linux file system can read and write to NTFS as well. Linux roles and permissions. So we looked at this earlier on a live system. This is where we have those octal values of 421, 421, 421. We've got the user, the group, and others. So we can set the user to read, write, execute, and everybody else to nothing by setting up 700. If we have a D, indicates a directory. If we have a line, indicates a file. Okay. We've got such things as hard links and symbolic links. We use the ln command in order to create links. So a hard link will point to the same location as the original file. And if we change one file, it changes the other. A symbolic or a soft link uses the ln space -s. So we use the -s option. This will create a symbolic link. If we delete the original file, the soft link is linked to the original file that no longer exists. Don't care with these things. The advantages of a soft link is that we can actually link to a directory. Hard links are you cannot link to a directory, but with a symbolic link you can. Hard links are also limited to the file system in which they were created, whereas symbolic links can link to a file in another file system. So these links are quite useful. Rather than having to recreate a file in another file system, we can use a symbolic link to link directly to it. The X windowing system. The X windowing system is the framework for the Linux graphical user environment. Provides functions for drawing and moving the window, as well as interacting with the mouse and the keyboard. X Windows actually works as a server, so it can send the graphical window over the network to a remote computer. So this is a bit like if you've ever used something, for instance, like terminal services or VNC, that type of thing. You can actually set X Windows up on a system and look at the graphical user interface across the network on another system. You can have desktop environments that go on top of the X Windows system. Typical Windows managers are GNOME and KDE. So looking at a Linux GUI, this is an Ubuntu GUI. They all vary. Package management. You'll have graphical package management tools, like on a Debian system it will be Synaptic. On different versions of Linux or different distributions, you'll have different type of package managers. So it's the advanced package management tool for Debian based systems, whereas it's Yum for Red Hat based systems. Debian normally uses dpkg to do the work, whereas Red Hat uses RPM. The files are known as deb files on Debian. They're known as RPM files normally on Red Hat systems. On a Arch system, we actually use Pacman, believe it or not. It's known as Pacman. Keeping the system up to date, apt-get update, apt-get upgrade. I'll show you something very quickly on that before we call it a day. Processes and forks. I also want to show you something very quickly on how the ps command works, top and kill. Malware. Linux is generally considered more resistant to malware than other operating systems, but it's not immune, so you should make sure that you set up a virus checker. Now I have had Linux systems and customers' Linux systems that have not had a virus checker on for years and they've never had a problem, but it's not worth taking the chance. A rootkit is installed in an operating system kernel and it's often used to establish hidden backdoors. So check rootkit is a program that will check for rootkits and remove them. However, sometimes the removal is almost impossible and you might have to reinstall the operating system. Piping of commands allows us to combine multiple perform complex tasks, so we can pipe the output of one command into the input of the next command. Okay, before we finish completely, I just want to show you a couple of those things. So for instance, ps, we'll do a very quick demonstration of that. So this is a nice one that you can show your students. What we'll do is we'll create another window. So I'm just going to open up another terminal. And in that terminal, I'm going to ping the loopback interface. And the Linux ping will ping forever. It will just carry on going until you hit Control-C to stop it. What I'm going to do now is I'm going to type ps -ef. And if I can, let's see if I can do this. you notice the ping is still going. We have the PS-EF. We have the line ping 127.0.0.1 with a process ID of 2043. What I'm going to do is I'm going to kill 2043. And you'll notice what it did was it terminated the ping. Okay, so I'll be back. I'll run PS-EF again. Because it's a new instance, it's got a different process ID, 2045. I will kill 2045. Terminated. Just like good old Arnie. Okay, in fact we're about 10 minutes over now, so I'm probably going to have to wrap that one up. I hope you found that useful. We've done a Linux installation with a graphical user interface using Debian. We've had a little look around the command line on the Linux operating system. I would like to have been able to spend a little bit more time, but we're actually now at 1 hour and 10 minutes, and I know that you've all got homes to go to and wives to welcome and dogs to walk and sandwiches to eat and beers to drink. So what I'd better do is I'd better sign off at this point. Thank you very much indeed for tuning in. I'll do a supplementary video on how you add users to the system. That was very strange. Up till Debian 9 you could simply add a user by doing a user add command, but anyway, not to worry. I'll have a little look at that. Thanks again for joining us. Join us again next week on the 7th of October for Chapter 4, Network Protocols and Services. Best wishes to you all.